So these are the doubts from October, November 2020 paper. A car is traveling at a velocity of 2, so that's the starting speed of the car, and it accelerated at a constant acceleration of 0.2, and it took 2.5 minutes, but time should always be in second. So you have to convert these 2.5 minutes into seconds. So it will be 2.5 times 2.5 times 60. That will give 150. So the time is equals to 150 seconds. We need the final speed. So we have the formula for acceleration. Acceleration is the change in the velocity divided by time interval. So acceleration is 0.2. The final speed, we don't know. The initial speed is 2. And what about the time interval? It is 150. So 150 is divided, other side will be multiplied. So it will be 0.2 times 150, which is 30. So when you multiply this, you will get 30 is equals to V minus 2. And this is 2 is subtracted, other side it will be added. So 30 plus 2 is equals to V, or we can say 32 is equals to V. So the final speed will be equals to 32 meter per second. A sphere P, which is made up of a steel and having a weight of 10 Newton. So like example, there is a sphere that is on Earth. And how much is the weight of this sphere on Earth? That's equal to 10 Newton. And there's another sphere Q is there. So this is sphere P that is on Mars. And the weight of this sphere is also 10 newtons. So both spheres have the same weight, but different planets. The gravitational field strength of the Earth is greater than the gravitational field strength of the Mars. So as we know, like we have the formula, weight is mass multiplied by gravity. We are getting the same weight. The weight on the Mars and the weight on the Earth is same. So if the gravity of the Earth is more, then the object should be lighter to have the weight of 10 Newton. Where the gravity of the Mars is weaker, so the object should have more mass to get the result 10. Because the product of mass and gravity is weight. So if gravity is stronger, mass should be less to get the answer 10. Because we want the answer to be 10. So if I say the gravity of the Earth is 10, what will be the mass of object to get the final result 10? So the mass of object should be 1. And for example, if I say the gravity of the Mars example is 5. So what should be the mass of an object to get 10? So it should be 2. So the object which is on Mars should have more mass as compared to object on Earth. To have a weight of a 10 Newton, it should be lighter, so that the product of mass and gravity should be same. That's why B is the right answer. That mass of a sphere P is less than the mass of sphere Q, because if its mass is less and the gravity of the Earth is more, the product will be 10. But for gravity of the Mars is smaller, so the mass should be more, so that we get the product as 10. In this question, the diagram shows three forces which are acting on an object. What is the value of resultant? First, a 9 Newton and 1 Newton are in opposite direction and in x direction. So as they are in opposite and in x direction, so what will the result of 9 and 1? So it will be 9 minus 1, which is equals to 8 Newton. So a horizontal force will be there, 8 Newton. And there's a 6 Newton upward force or a vertical force of 6 Newton. So there will be a vertical force of 6 Newton. Now, how to get a resultant of a two perpendicular vectors or two forces which are 90 degree or perpendicular to each other? We use the Pythagoras theorem. So what is the Pythagoras theorem? That is the base square plus perpendicular square in a root. The 8 square is 64, 6 square is 36 in a root. So 64 plus 36, 100 in a root, and square root of 100 is equals to 10. That's why B is the right answer. Is it clear, this one? What if in the question there was another force of 2 Newton downward? So then how we will solve this question? Same manner we will solve. 9 Newton is towards right and 1 Newton toward left. So resultant will be 8 for them. And 6 Newton up and 2 Newton down. So resultant will be 4. Again, the two forces become perpendicular. So how we get the resultant? We'll use a Pythagoras theorem. Like perpendicular square plus base square in a root, we get the resultant. Is it clear, this one? In this question, a stone is dropped from rest from a height of 2 meters. The planet has no atmosphere. The speed of a stone before reaching the surface is 3.8. What is the acceleration of a free fall? So example, there's a stone which is dropped from certain height, 2 meters. First, we'll find and the speed at which it hits the ground, that is 3.8. And the starting speed, because it is dropped from rest, so starting speed is 0. So whenever the speed is not constant, speed is changing, we use a formula that average speed is equals to the distance divided by time. And what is the average speed here? It starts with 0 when the speed is changing, the initial plus final divided by 2. That's the average speed. So what will the average speed here? It will be 0 plus 3.8 divided by 2, which is 1.9. So average speed is 1.9 for when it is falling. The distance is 2 meters and time we don't know. If we need the time, so it will be 2 divided by 1.9. So 2 divided by 1.9, that will give us the time it will take to fall. That is 1.05 seconds. So it took 1.05 seconds to fall this 2 meter. Now we need the acceleration of a free fall. So what's the formula for acceleration? It's a final minus initial divided by time. The final speed is 3.8, initial speed is 0, and the time it took 1.05. So acceleration will be 3.8 divided by 1.05. So 3.8 divided by 1.05. That's equal to 3.61. So acceleration will be equals to 3.61 meter per second square. So C will be the right answer. So first what we did, we calculate how much time it will take to fall. That is by using the formula for average speed is distance over time. So average speed when object speed is not constant, it is continuously changing. So how we take an average, it's a minimum plus maximum divided by 2. That's an average. And that average speed, after getting an average speed, distance divided by average speed, we get the time to fall. And if we know the time, we use the acceleration formula, that change in velocity divided by time, we calculate the acceleration. Which statement about a thin converging lens is correct? So if we have a thin converging lens, a convex lens, all the light rays refracted by a lens passes through principal focus. That's wrong. Only the parallel light rays will pass through principal focus, but not all of them. So this is wrong. All rays in parallel to principal axis will refract through a focus. That's correct. Parallel light rays will always pass through focus. So the light rays which are parallel to principal axis will always pass through the focus point. Then when a white light, which is a combination of violet, indigo, blue, green, yellow, orange, and red, where violet bends the most and red bends the least, because the speed of a violet decreases more than speed of red, or violet is traveling slower as compared to red in glass. So which description, what happened as a light passes into a prism? The speed of a red light is less. No, it's more than violet. The speed of a red light is greater than speed of a violet, or speed of violet is less than red. That's why violet bends the most and red bends the least. So the one which is having a higher frequency will show a greater change in speed, as compared to a wave which is having a lower frequency. A beam of particle move through a magnetic field. In which situation do the particle experience a magnetic force? The particle must move perpendicular to the magnetic field. Like if this is a magnetic poles, north and south. So the magnetic field between north and south and the motion of the particle both should be perpendicular. So alpha particle moving parallel, this is totally wrong, because when the particles are moving parallel, they should cut the magnetic field. If they are moving the parallel to magnetic field, they don't experience any force. Here beam of neutron are not charged particle. When the charged particles are moving perpendicular to magnetic field, they experience the force. So if it is electron passing perpendicular, yeah, that's right. If electron passing perpendicular, then it will experience the force. Then this statement will be correct. But they mention it is parallel, that's why it is wrong. Is it clear, this one? So the particle or even a wire should be perpendicular to magnetic field to experience the force. This is blue line is and green line both shows deceleration, but one shows that deceleration is increasing because the angle is increasing. So the deceleration is increasing. Other shows the angle is decreasing with x-axis, so deceleration is decreasing. And this shows a constant deceleration. An optical lever is very sensitive device for detecting a small rotation. A lamp sends a narrow beam of a light on a small plane mirror, and its shaft whose radiation is being measured. The beam of a lamp reflects from a mirror to give a small spot on the light, and the shaft in the mirror rotate at an angle of 1 degree. The spot moves along the scale. The angle theta shows through which the reflected ray will rotate. So how much the reflected ray will rotate? It's always to achieve the high sensitivity. The table shows an angle theta through which the reflected beam is rotated and the condition required for high sensitivity. Which row is correct? The theta, to achieve a high sensitivity, lamp and scale need to be close to a mirror as possible. If they're close to mirror as possible, then what will happen? The angle what we measure, because like here it is representing a lamp. This is just to measure the angle accurately as possible. This is an optical lever which is a very sensitive device for detecting the small rotation. Like if say this is a shaft, what happened? A beam of a light is reflected, like strike, and it bounce back. But as the shaft rotate, the light will be reflected. Like theta is the angle of how much the reflected ray is reflected from a small mirror on the shaft. So they're saying the optical lever is there, which is very sensitive device for detecting a small rotation. And a lamp send a narrow beam of a light. So it is sending a narrow beam of a light and receiving it. Then a mirror which is attached to a shaft rotate, like whose rotation is to be measured. Like we want to rotate how much the mirror has rotated. The operation of the device is shown here. The beam from a lamp reflects from the mirror to give a small spot of a light on a scale placed above the lamp. So there's just a scale above the lamp. So like as the shaft rotate, it will give the position of a spot. The shaft and a mirror rotate through 1 degree. So like this mirror, how much the angle has changed? Initially, it was like striking and bounce back. Now it has rotated 1 degree. from the original position. This is a rotation. So table shows the angle through which the reflected beam is rotated and the condition required for high sensitivity. So which row is correct? How much if the shaft rotate 1 degree, how much the theta will be there? Theta is the total angle between, like if I say theta is the angle between the incident and the reflected. So if the shaft rotate 1 degree, how much the theta will be? Like if I say this shaft, I just rotated 1 degree. So what will happen to the theta? Because if angle of incidence is 1 degree, angle of reflection will also be 1 degree. So what will, like if this angle is 1 degree, so how much is this angle? This angle will also be 1 degree. So what is the total angle rotated? That will be equal to 2 degrees. Is it clear? The first part, how the angle is 2 degrees. Because the mirror on the shaft is rotated. This was a mirror, and then the mirror rotated 1 degree from the original position. So if this angle increased by 1 degree, how much will be the angle of reflection? The angle of reflection will also be 1. So the total angle which is rotated, that's equal to 2 degrees. No, angle of incidence and angle of refraction is not 0.5. Only thing what we did, there was a mirror, and this was a, say example, a mirror was like this. The light strike and light bounce back. Now what we did, from the original position, we rotated only this mirror by 1 degree. So when the light strike and we rotated by 1 degree, so this angle is 1 degree. So the angle of reflection should also be 1 degree. So what is the total angle between the incident to the reflected? That's equal to 2 degrees. Is it clear till this point? How the angle is 2 degrees? Now, the second thing, we want to make it sensitive. Sensitivity means for a smaller change, there is a greater value. Like when a value change is small, but the measurement change should be larger. So when they're saying if a lamp is closer, two possibilities are there. When the shaft and the lamp are closer, and the other possibility when the shaft and the lamp are away. So when it rotates 1 degree, when the lamp is closer, when it rotates, the reflection will happen like this. But when it rotates 1 degree and it is further, so what will happen? For 2 degree measurement, like this will be a greater, that distance between the incident and the reflected ray will increase. Like this is 2 degrees, this is also 2 degrees. But if the mirror and the lamp, the mirror on the shaft and the lamp are closer to each other, so the distance, the spacing between the spots which changes, that will be smaller. But when they are far from each other, then the spacing between them will be more. So when the spacing is more, the sensitivity will be higher. Is it clear? How the sensitivity is affected by sensitivity means like a small change in a measurement can be recorded easily. So to make it more sensitive, we should be able to increase the spacing between them. So when the lamp is far and the mirror from the mirror, so when the reflection happen for 2 degrees, the spacing, the change in the angle or the length will be more. Yeah, spacing between the lamp and the spacing between the shaft and the lamp is increased. As a result, the reflection, the spot will be far from the center position. So we can measure that change easily, how much the length changes. Like here, in this case, say this was say 1 meter. And when we measure this, maybe 20 centimeter. But what we do, if we move this shaft far, the angle remain 2 degrees. The change in angle remain 2 degrees. But when it hit the screen, the scale, it will hit the screen far from the position. So we can measure this height easily because it will be a longer length or a greater height, which will make it easy to record. Is it clear, this one? High sensitivity means easy to measure. So which one will be easy to measure means high sensitivity. So which length will be easy to measure when the spot is moved smaller distance or a spot is moved larger distance? High sensitivity achieved means for a small change, a greater change in length happen or occur. So this will have, that's why example. So we say high sensitivity can be achieved when we move the lamp far from the, when we move the shaft and the lamp far from each other, we'll get a high sensitivity. Like easy to measure or record. Is it clear now? So simply first, when we rotate this by 1 degree, now angle of incidence is 1. So angle of reflection should also be 1 and the ray is reflected. And it move away from the spot and that we measure how much it has shifted. But if we keep the lamp far from it and rotate 1 degree, the ray will rotate 2 degrees. But the spot which will appear, it will be greater distance from the original position, which will make it easy to record or it will increase the sensitivity. Then in a bimetallic strip, the one which expand more, as you can see, the size of a metal P increase more than Q. So P expand more than Q. Q will also expand but less. So which statement is correct? The metal P, as they're expanding, so contraction is not there in this case because the size is changing. So P expand more than Q, that's why it bend outward toward the side of Q. How we know P expand more? Because you can see the increase in size of a P is more than increase in size of a Q. If you measure these lengths, compare this length with this. So the side where it bent outside, other way, like example, left side is P and right side is Q. And when we supply the heat energy, it bend in this manner. So which one expand more? So it means P expand more than Q. The increase, that's why it bended in opposite direction. So which one expand more? It opposite direction it bend. If Q was expanding more, then which direction it will bend? It will bend upward. Is it clear, this one? This is the same question I have already discussed in the beginning. How we know which contract more? The one which expand more, the same thing which that will contract more. If P is expanding more, P will contract more as well. But why here contraction is not the right answer as it is heated. If it was cooled, the same thing. So the one which expand more will have a greater contraction as well. How we know that which is contracting more? For example, this is, it's basically the same idea because P is contracting more. So if P is contracting more, the P size will decrease more, so it will bend like this. This will be P and then Q will be there. Because P, the one which is changing size more, reduce in size more, that side it is bending. And the one which expand more, opposite side it bend. So in a contraction, if a question is it is cooled, which contract more, the one which side it is bending. And if they are saying it expand, we check for in expansion, which expand more, the opposite side will it bend. Like if it is bending towards side of Q, it means P expand more. And in contraction, if it is contracting in a side of P, it means P contract more. This I already discussed. The diagram shows a stand. The stand holds a heavy mass above the bench with two changes would make it more stable. If we want to increase the stability, we should increase the base area and lower the center of the mass. These are the two things. So lower the center of the mass and make a base wider. We like increases the base area and lower the center of the mass increases the stability. So lower mass or lower center of the mass and make the base wider increases the stability. Like it will be stable in this manner. It won't topple.